Got another trigonometric integral for this video. You want to give it a try? Go ahead and pause the video. I'll be right back. Okay, let's look at this now. We got cosines in the denominator, sine in the numerator, and of course we know the derivative of cosine is minus sine. So let's start off with the U-substitution. We'll let U equal to cosine of x. So du would be derivative of cosine is minus sine, and this would be du or dx. So multiplying through by negative 1 minus du would equal to sine of x dx. So let's rewrite the integral now in terms of u. So in the numerator we have sine x dx. Sine x dx over here on the left, that's the same thing as du. So this will be du. And I'll leave the negative 1 there in this case. So negative 1 du. And then the denominator we got cosine squared x minus cosine x, and cosine is u, so this can just be replaced by u squared minus u. So we got a rational expression here for the integrand in terms of u. So we could do partial fractions on that. Let's bring this over here, minus 1, and then we factor the denominator into u, and u minus 1. Factoring out of u. So we have linear factors, none is repeated. So we could write this as a constant over the first factor of u plus another constant over the other factor, linear factor of u minus 1. Then we just multiply through by this common denominator here, which would be u times u minus 1. So on the left side, I'm just left with a negative 1. On the right side, multiplying through by u and u minus 1. The u cancels here, so this would be a, and that would be times u minus 1. Multiplying the second factor on the right by the expression u times u minus 1. The u minus 1 cancels, and it gives me a b times u. And then there's several ways we could do this. You can do the cover-up method here. We don't have that much here, so let's just do it this way. We can replace the value. This turns out to be an identity. So you can pick any values you want here for u to solve for a and b. So I'm going to pick, let's pick u to be 0. If u is 0, then this b term gets wiped out, and I get over here negative 1a is equal to negative 1. So solving for a, negative 1a equal to negative 1 means a is equal to 1. So I get a equal to 1. And the next one was solve for b, so let's replace, now let's eliminate the a. So let's let u equal to 1 now. Let u equal to 1, that wipes out this factor here, the a constant, and we get 1 times b is b. B has to equal then what's on the left side, that's been minus 1, so b is equal to minus 1. So now we can expand this. So we got integral of negative 1 over u squared minus u. So this is going to equal to then, the a is 1, so this will be 1. Put a where the 1 where the a is, and that's going to be over u. And then b is negative 1, so put a minus 1 where the b is. That's over u minus 1. You can break it up into two integrals if you want. I'll just leave it like this, and we'll just integrate term by term. So in this one then, this is, again, if I treat this one as the first integral, 1 over u du, that's just your natural log of absolute u. So natural log of absolute u. But u is cosine of x. So I have this. And then it's minus, and look at this integral as 1 over u minus 1. That again is the natural log of absolute u minus 1. But u is cosine, so this will be cosine of x minus 1 plus your constant of integration. And that's really your answer. But you can use some properties of logs and write this as a single log here for this the first two terms. So I can write this as a natural log, and that could be absolute cosine of x over, because of the minus here, over absolute cosine of minus x. So writing that as 1 absolute value, it should be natural log cosine of x, and that would be cosine of x minus 1 plus your constant of integration. So that's your final answer for this one. Natural log of absolute value of cosine of x over cosine of x minus 1 plus your constant. Thanks for watching. We'll see you next time.